So the review problem number 1 is asking you to find the GCF. That means we have to factor out the greatest common factor. So that means what? You have to ask yourself what is common in both terms. And when you look at the both terms, we have in 3x plus 24, there is only one variable, okay? And it's not in both terms. So you have to look at the coefficient in the first term is a 3 and ask yourself, will 3 go into 24? And how you do that is you just simply take the 24 and you divide by 3. Okay? So, in other words, what's on top, remember, goes in the house. And you ask yourself, how many times does 3 go into 2? And that's 0. And 3 goes into 24 8 times. So, the 3 goes into both terms. So, when you factor out the GCF, you put that 3 out to the left of the parentheses, and then you divide out the 3 in the first term. So 3 divided by 3 leaves 1, x. Then 24 divided by 3 leaves the 8. Okay? Number 2 is asking for the GCF. Okay? So you're having to look at both terms and ask yourself what's common in both. Notice that there's a variable in both, and when you see that there's a variable in both terms, the same letter, okay, then you factor out the variable with the smallest exponent. When you're missing an exponent, it's automatically a 1 right there. So x to the 1, we're going to factor out x to the 1 because it has the smallest exponent. And then you ask yourself, will 4 go into 14? No. Since 4 won't go into 14, you start reducing the number, okay? Since 3 won't go into 4, right? You don't use 3, then you go to 2. 2 goes into 4. Then you ask yourself, does 2 go into 14? And yes. So the GCF here is 2x, right? And if I were to continue factoring, right, it would look like this. I would factor out the 2x, start my left parentheses, and then I would divide that into 4x to the third. Well, 4 divided by 2 is 2. X to the third, you just subtract the x to the 1, right? Just 3 minus 1 leaves x squared plus, remember, 14 divided by the 2 is 7, and the x divided by the x is 1. So then you close the parentheses. So this is now completely factored, okay? But we were only looking for the GCF. All right, number 3. Okay, so this is a difference of perfect square, right? Difference of squares. So we want to factor completely. So when you see a difference of squares, it's telling you in this problem to use difference of squares. That's because there's a minus sign between two perfect squares. Okay? When you know that you have perfect squares, in other words, to test that you have perfect squares, you would just square root both terms. So the square root of 4x squared is 2x. So that's a perfect square because you can take the square root of 4 and get a 2. The square root of x squared gets x. Then you see if the square root see if you can take the square root of 25 and get a whole number, and you can do. So the answer after taking the square root of 25 is 5. So we have difference of squares because it gives us whole numbers. So once you know that you are dealing with difference of squares, what I like to do is, set up the two sets of parentheses right like that, and then just put the 2x, 5, 5, and it's plus and minus right off the bat. Okay, and it doesn't matter if you put the minus 2x minus 5 and then the 2x plus 5. It doesn't matter. Okay. Number 4. Okay, factor the GCF and then factor completely. All right, like I showed you on number 2 just a second ago. We're going to factor out the GCF, and then we're going to completely factor. So what you want to see is that there is the variable x in both terms. So when you're missing an exponent, it's automatically x to the 1. So that is going to be our GCF here. Okay? Because there's at least one x in x to the third, right? So that's why we use the variable with the smallest exponent. So we want to remember that. Now, you want to ask yourself, will 8 go into 242, right? In other words, you just start dividing. So you just get your calculator and you do 242 divide that by 8 and see if it gives you a whole number. This 8 will not go into 242. It leaves a decimal. So then you have to start reducing. All right. 7 won't go into 8. 6 won't go into 8 evenly, right? Leaves a decimal. And you keep working yourself down, right? The next one has to be a 4. We know 4 goes into 8. Does 4 go into 242? You start dividing, okay? 242 divided by 4. That leaves a decimal, right? So 4 won't go into it. So you keep going. Let's jump down to 2. We know 2 goes into 8, and we should know that 2 goes into 242, right? So 2 is our 2x is our GCF, right? So the GCF is 2x. Then it says factor completely. So I'm going to start my left parentheses. I know 2 goes into 8 4 times. And I know x goes into x to the third 2 times. So it's going to be x to the second, right? Then minus, and then we know that 242 divided by 2 is the 121. And the x cancels out the x when you're dividing. Now, so what we've done here was factor out the GCF here, and then, because these aren't perfect squares, right? 8 is not a perfect square, neither is 242. So once we factored out the GCF, we see that we have perfect squares here. In other words, when you take the square root of 4x squared, we get a 2x. When you take the square root of 121, you get 11, right? So this is a difference of squares. So we want to continue with factoring completely. See, we need to continue factoring completely. So I'm going to put 2x and then 2 sets of parentheses with the 2x and 2x, 11 and 11, plus minus. Okay? Number 5. Okay, so number 5, this trinomial, and this says here, a factor of the trinomial ABC. This A is this coefficient, okay? So the A here, B, and C. So we have a trinomial ABC where the coefficient of the x squared A is 1. When that's 1, it's really easy, right? You just find the factors of the 40 that add or subtract to 13. So it's just automatically 2 sets of parentheses here. All right. K squared is K and K. 1 and 40. Okay. So factors of 40. I'm going to go ahead and write this down. Factors of 40. We got 1 times 40. 2 times 20. Does 3 go into 40? No. 4 does. 4 times 10. All right. Continue asking yourself what goes into 40. All right. We have 4 times 10. We have 5 times 8. Now, right here, see, I kept going because 1 plus 40 does not get 13. 2 plus 20, nor subtracting. There's no way I'm going to get 13 after adding or subtracting those factors. In here as well. But here I can stop because I can add 5 and 8 and get that 13. So my factors that I'm going to use are the 5 and the 8. Okay? I need them both to be negatives so that because when I add two like terms that have the same side, you add, right, and keep the sign. But when you multiply, negative times negative is positive, right? So there's my factors. This is my factoring completely of that trinomial. Okay? All right, number 6. We have a trinomial just like number 5 where A is equal to 1. Remember, where the coefficient of the first term, right, the leading term, is 1. All right? So when you have no GCF, to pull out first, then you just start factoring regularly by setting up 2 sets of parentheses. Put your B and your B, and then your factors of 10 that add or subtract to get a 3. Well, you should know that the factors of 10 are 1 times 10, 2 times 5. If I add, I get a 7. If I subtract those, I get a 3, right? There they are. I want to get a 2 and a 5, and I need it to be negative 3, so I want the 5 to be negative and the 2 to be a positive. Then ask yourself, does a positive times a negative get a negative? Yes. So there you go. That number 6 is done. Okay, number 7. Okay, this one here is a trinomial. Okay, hang on 1 second. I'm going to see something here because when this printed out, I'm not sure what this star here. Let me look at that real quick for number 7. Okay, so the trinomial, 3a squared plus 5a minus 2. Now it says here that that this particular trinomial a is not equal to 1. That means we're not talking about this a, we're talking about this a. It's a little confusing where you've got your first, the coefficient of the first term is a, B, C. So when your first term here, the A is not equal to 1, right? You have to take in those factors of that first term. So what I like to do is come right above, up at the top. This is easier because 3, is prime, so it's only, the factors of 3 is 1 times 3. and the factors of 2, easy, 1 times 2, right? So this is not bad, right? This is good practice though for you. So you set up 2 sets of parentheses, and I like to set my parentheses so that these 2 line up in the middle, okay, between the 3 terms, and then I start separating, and then I start putting my factors in, okay? So 1a is just a, okay, so my factors of 3 will go here and here, so I'm going to put 3a here, and my factors of 2 go in the last, right, 1 and 2. Now, we need to get a 5, right? So you take your outer, that's 2, and your inner is 2, and you add or subtract to get that middle. So the outside 2 terms, right, 2a, and the middle 3a gets 5a. So they both have to be positive. So if here's the problem here, this might be a mistake here, because the middle term has to be positive, but then I see the mistake here on number 7. Number 7, there is no way to get a -2 if both of these are positive, right? In order to get a positive 5, both has to be positive. And in order to get a -2, one of these has to be a negative, right? So when you multiply, right, a negative times a positive, that's not going to work. So let me look over here, and I see okay, all right, here's let's take a look at this one. That's a 3 and a 4. Okay, not more. A 3, 1, 6. Okay, a 6. So here's the thing. A 6 minus 1 would get that 5. So this one here, I want to show you. By putting this term, instead of putting 3a here, we're going to put the 3a here, the 1, and we're going to do the a plus 2. Now, notice that this happens, okay, where, okay, let me go ahead and put in the coefficient here. That's a 1. That's this 1 here. So you put your 1 in your 3, and then you put this 1 and 2 here and here, right? Now, when you can't get that to work out, right, and get this, you have to start manipulating those factors, okay? Notice now, if you put the 3 out front here and the 1 here, look at what happens. You take the outer 2, right? That's a 6a. You multiply 6a, and you take the inner, and you multiply. You get a 1a. Here is when, okay, we need to subtract. We must get a positive, right? So 6 minus 1 is 5a. But then when, all right, so what 2 numbers when multiplied got us that 6a? Well, it's the outer 2, so we want that to be positive, right? And then we needed to subtract. So right there we needed to put that minus sign. So, and then when you multiplied a -1 times 2, we got that -2 back, right? So here, that's what's tricky when the first term, right, is not 1. So be careful there and watch out. This is not hard. You just got to, keep in mind that just because you started off with one setup and it didn't work, that doesn't mean the problem was set up wrong. It just means you need to continue thinking, okay? And go to number 8. Okay, number 8, we have this trinomial where a is not equal to 1. All right, so we want to ask ourselves, is there a GCF? No. clearly you should know that there is nothing that's going to go into all three of those. So we want to go ahead and just factor regularly. Notice I like to set my two parentheses up here close to the middle and spread out these two parentheses so I can fit in my two, my binomial, right? The two terms that go into this one and two in this one. I got to be able to fit them in there. All right, so now what we want to do here is find the factors of 4, which would be 1 times 4 and 2 times 2. And then the factors of 25. Let's start. We know that that would be 1 times 25 and 5 times 5. What we want to get is a 25 in the middle. So let's take a look at, I'm going to look at the 1 and the 4 and the 5 and 5. So if I did 1, I do the outer now. I do the 1 times 5, that's 5, and do the middle. 4 times 5 is 20. So there's 25, right? So I'm going to go ahead and put in the 1x squared, that one there, okay? Goes for, then the 4. Oops, no, don't put the square. And then 4x, right? So 1x and 4x. And then we put the 5 and the 5 because that's your constants. There's no x, go with that. And we need it to be negative, right? Now, so when you take it and you do the outside, you do the 1x times 5, and then you do the middle, then we need it to be negative. So they both have to be negative. So when you multiply negative 5 times negative 5, you get your positive back, okay? So there's your factors for number 8. Okay, number 9. All right, on number 9, we are going to we have to see that we have two fractions and that we are multiplying. Very important right there, that we are multiplying. So what we want to do when you're multiplying fractions is see if you can cross reduce, right? Always try to reduce your fractions whenever you can. If you can't, you can't, right? But always reduce your fractions. Now first, in order to reduce fractions involving rational expressions, you have to factor. Okay, top left, nothing to do. Bottom left, okay, two sets of factor regularly. Two sets of parentheses, x and x. The factors of 6 that add to 1, 2 and 3. 2 and 3, right? I can add up, or add or subtract to get that 1 right there in the middle. Right here we need the middle coefficient, right? When you add or subtract them, you need to get a positive 1. So I need to put a positive here and a minus here. Now negative times positive is negative. We're good there. Okay. Now top right, that's the difference of squares. So let's go ahead and get our x and x separated. Square root of 9 is 3. Okay, and it is plus or minus right off the bat because that's the difference of squares. And on the bottom, the only thing you can do is factor out the GCF, which is a 6, leaving x minus 1. Now we start to cancel out, right? Cross reduce. This x minus 1 here cancels out this x minus 1. This x plus 3 cancels out that x plus 3. That's an x minus 2. Okay, so what I have left here on top is I have the x minus 3 on top. And notice right here, you got to pay attention to what's left over. We got that 6 right there. So that's got to be multiplied to the x minus 2. So 6 times x minus 2. Now, if you look at your answer choices, make sure you're not having to distribute that 6. Otherwise, you may have to distribute the 6. So, okay, so it's left like this. Okay, so that's it. All right, so number 10, which expression is equivalent to the given one right here? So, all right, so right here, we have to factor all 4 of those, right? By now, you should be pretty good. Now, luckily, one of the review problems that we had wanted you to factor out the GCF before doing the difference of squares, right? So right here, even though we have a difference of squares, right? 100 is a perfect square. Let's pull out the greatest common factor first. So we know 4 goes into 100, right? 25 times. So let's go ahead, and I want to rewrite this right here below here. So that actually, let's go ahead and show right up here that I'm going to factor out the 4, and that's all I can pull out. So it's going to leave x squared minus 25. Okay, now that's the difference of squares still. Okay, so let me go ahead and write out the problem again for you. Over, I'm going to bring all this down here. X squared minus 7x plus 10 times 5x minus 10, 4x plus 20, okay? Now, you can see that we have a difference of squares on top still, which we still have the 4 times and then 2 sets of parentheses, x, 5, and 5, because that's the square root of 25, right? Plus minus. Okay? Now we no longer use this anymore. We're using it up here in the blue. Down here, it's just factoring regularly. Okay? X. Factors of 10, that gets 7. That's 2 and 5. Okay? We need them both to be negative, so when you add, keep the sign to get negative. When you multiply, you get your positive. Okay? So up here, we've got a GCF, so I'm going to factor out a 5. All right, so 5, and then that leaves x minus 2. And on the bottom, the GCF only, so 4, and then x plus 5. Now, we start reducing. You see that we have an x plus 5, cancels out the x plus 5. This x minus 5 cancels x minus 5. X minus 2 cancels x minus 2. What's left on top, though, be careful. Still got this 4 and this 5. You got to multiply, right? We're multiplying. So what is 4 times 5? That's 20. What's left on the bottom? Don't forget, got to stay on the bottom. And this is going to reduce to 5. Okay? Number 11. We have to multiply still, okay? We're multiplying 2 fractions. It's just this time, the symbol is the x for multiplication versus the multiplication dot in number 10. We still have to quickly look at what we've got. We got to factor all 4 of those, okay? This one on top is just factoring regularly. There's nothing common in all, so we just start factoring. The factors of 10 that get 11, well, that's going to be a 1 and a 10. Okay? They both have to be positive because I need to add them to get 11. And then I'm also, when I multiply, positive times positive, keep a positive. Okay? Now, on the bottom, we see GCF of a 2x. You should see 2 goes into 20 evenly, right? So factor out the 2x because there's an x to the 1 here. So that leaves x plus 10. Okay? On top right, 2 goes into 14. You should see that. So 2x. and then x plus 7, yes. Okay, on the bottom, just regular factoring. Okay, so x, the factors of 14 that get 9, that's 2 and 7. Okay, both are positive. Now, can we reduce? Okay, I can see that I can reduce x plus 7, the x plus 10, the 2x, and the 2x, leaving me with what's left over is the x plus 1 over the x plus 2. Okay, this one here, right? I'm sorry, let me get over here. Okay, so what's after seeing what's left over, the x plus 1 and the x plus 2 leaves us with the x plus 1 over x plus 2. Okay, number 12. All right, so number 12. All right, we're dividing. So when you divide, you rewrite the setup so that it is the first fraction, keeping it the same. So we got 8x minus 16 over 2x plus 18. Turn this into a multiplication, flipping the second fraction. So x squared plus 5x minus 36 over x squared minus 16. Start factoring. Okay, so in this problem here, we have us a GCF on the top left, 8x minus 16. The GCF is going to be 8. So I'm going to factor out at 8. Leaves x minus 2. I'm going to set up regularly factoring here. X, the factors of 36 that get 5. Okay, 1, 2, 3. Let's see if 3 goes into 30. Let's see, 3. So 3 and 12. Let's see what 36 divided by 4. Okay, so what I did was quickly going through and got something that looks like I might be able to work it. So 4 and 9 are my factors I need to work with on 36, because 4 and 9, right? If I add it, I got a 13. If I subtract, I get a 5. So plus. So I quickly went through. I said 1 times 36, 2 times 18. I kept working. And I kept working until I got to 5. So I saw 4 and 9. 4 times 9 got 36, and I subtract it, get to 5. The 9 had to be positive. So when I subtract, I keep it positive. And I multiply, negative times positive stays negative. Bottom left, factor out GCF, that's a 2. X plus 9, and then difference of squares. 2 sets of parentheses, x, 4, 4, plus, minus. Now, reduce. Start canceling. X minus 4, x minus 4, x plus 9, x plus 9. Okay, 2 goes into 8 4 times, leaving this as a 4 times x minus 2. Over, right, don't forget what, you got to continue looking what's left over the x plus 4 right there, okay? All right, number 13. All right, so number 13 says we have to divide. So it's the same as, it's the same as 14. Same as 12. Is so when you see a division problem, you want to keep the fraction the same, the first fraction the same. So z squared plus 12z plus 27 over, let's put that as 7. over z squared plus 13z plus 36. Now change this to multiplication. Okay, see if I can get all this in there. And flip the fraction. So z squared plus 6z plus 8 over, and then put the top fraction right on top part on the bottom. So z squared plus 3z. Start factoring. Okay, this is all about factoring. All of this 9 weeks. Okay, so far been most of this year has been factoring, right? You know. By now you should know. Okay, there's no GCF. We're going to factor regularly, right? So z and z, factors of 27 that get 12. Okay, 3 times 9. Okay, 3 times 9. Since both are positive, they're both going to be positive. Down here on the bottom, factor regularly, no GCF. Z, factors of 36 that get 13. Well, we just did 36 a second ago and add 4 and 9, right? Adding those get 13. So I want the 4 and the 9 plus and plus because they're both positives up here. Up here on top left, factor regularly. There's no GCF. Okay, let me scoot this over. Going to be tight fit there getting this in. Okay, separate. So z times z, factors of 8 that get 6. So that's 2 and 4. Both are positive, so they both have to be positive here. And then the only thing we have down at the bottom is a GCF. So factor out the z, leaving z plus 3. Now reduce. All right, this z plus 3 cancels this z plus 3, z plus 9, z plus 9, z plus 4, z plus 4, okay, leaving the z plus 2 over z. Okay? Number 14. Dividing, same thing, right? We want to keep the first fraction the same. So n plus 8 over n minus 3. Turn that into multiplication. Flip the second. 4n times n minus 3 and 3n squared times n plus 3. Okay. Now, so after flipping, you should see that we can, so, you know, make sure that you're not getting confused. Put parentheses around those two terms, okay? So now we can cancel out n minus 3, okay? All right, let's see here. See what else we got. All right, let's go ahead and see what happens here if we multiply the 4n. Let's just go ahead and put that together. We got 4n times n plus 8. That's what's left on top, and on the bottom we have a 3n squared times n plus 3. Now, let's see, what do we can see here? So what do I have here? Cancel out. Oh, here's my problem. And look at what happened right here. Look at this. When I flipped this, I put 3n squared, and then I did not write down the 8. Look at that. I used to always make that mistake so many times. All right, I went going too fast. Look at that. So now cancel. Okay. Now when you cancel and you're down to this point right here, Okay, and you have the 4n over 3n squared, right? You're going to reduce the n's. Now this is a missing exponent of a 1. When it's missing, it's a 1, right? So you want to say, okay, which exponent is larger? That means that if it's larger in the bottom, it'll stay in the bottom, right? So the variable will stay in the bottom. So 4 over, and then just subtract 2 minus 1. So 4 over 3n, okay? Moving to 15. All right, so 15, okay, we are add the following rational functions, okay? I didn't know that this was making such a mess on that next page, so I went ahead and I did print out okay, so let me use, so I've got 15. All right, so here's 15. Yeah, 15. All right, so we want to add. Okay, so in order to add fractions, you've got to have a common denominator. And in order to work with fractions that have rational expressions in them, you must factor. Difference of squares says x 2 plus minus. Okay? Ask yourself, what's missing in this fraction? X plus 2, right? All right, so let's go ahead and put parentheses x plus 2. And what I did to the bottom to make the common denominator the same, I have to do on top. So I'm going to put x plus 2 on top, okay? Now I can add. So when you're adding, it's going to be one large fraction with on top. We need to go ahead, okay, and we need to distribute here at the same time 5 to the x plus 2. So 5x plus 10, and then plus, right, 9 over, and look, the answer choice just says let's put all this back into this, x squared minus 4. So I'm going to go ahead and write down x squared minus 4 at that time as well. Okay, now on top we've got to combine like terms. Like terms are the positive 9 and the positive 10, right? They have no letters, so they're constants. Constants are like terms. So 5x plus 19 over x squared minus 4, okay? All right, let's go to 16. All right, so we're going to add. We're adding the fractions, okay, again. And so I'm going to rewrite this a little bit bigger so you can see that we have in the first fraction x plus 5. We're going to add to the second fraction x squared minus 25. That's the difference of squares. The factors of that will be x plus 5, x minus 5. And what's missing on the first fraction is an x minus 5. Let's go ahead and put this in parentheses. X minus 5 in parentheses, and put x minus 5 on top, because that's what we got to do once we figured out what we had to do to the bottom. Now I'm going to go ahead and distribute the 5 at the same time, writing this one large fraction. Notice that the answer choice is either going to be in factored form or it's going to go back to the original, okay? Just know that all of this is all of this, all right? So I'm just going to go ahead and write down x squared minus 25. It's either going to be, it's either going to be an answer with a b like this or this answer, okay? Let's see what the top does. So we got to distribute the 5 to both of those terms. So that's going to be 5x minus 25 plus 3. So I'm going to subtract, and that's going to give me a 5x minus 22 over x squared minus 25. So the answer was B. All right, moving on to 17. We want to okay, so we've got to, we see that we're adding, and so that what we want to do now is get us a common denominator, right? Okay, this is, all this is that x cannot be 0 because it'll put a 0 in the denominator, and it can't be -7 because it creates a 0 in the denominator. Now, when you have it like this, to get a common denominator, you are going to multiply. So it's going to be 2x times x plus 7. That's what you got to multiply those two, right? Now, what's missing in the first, okay, is the x plus 7. So I've got to multiply the x plus 7 on top. What's missing on the bottom, on the second fraction, is a 2x. So I got to multiply 2x on top. So now I'm going to go ahead and distribute the 4 to the x and the 4 to the 7. So I've got a 4x plus 28. That's 4 times 7, 28. 10 times 2, so it's plus 20x. Okay, so my like terms are here and here. Okay, let's go ahead and get those combined. So it's going to give me a 24x plus 28 over 2x over x plus 7. Now, I believe we have a GCF up here, all right? What's the greatest number that will go into both of those? Well, I definitely know 2 will, okay? Let's see if we can, let's see if 4 will go into both. 28 divided by 4. Yep. 24 divided by 4. Okay. I know 4 will. I think that's going to be it. Let me look at my answer choices and see how far I'm going to have to go here. All right, let me see what, let me just go with 4 real quick. So I know 4 will go into 24 6 times. 4 goes into 28 7 times. Now, I was really wanting to cancel out some more. Let me take a look here. Well, let's take a look at this. Now we know 2 goes into 4 2 times. I'm looking at the answer choices just to see if there's something else I can do here. And that would be a 2 times 6x plus 7 over x and then x plus 7. All right, let me come back to 17. I'm not seeing what I need to see right there. So I'm going to let you take a look at 17 while I keep going here so I can, so you guys have a pretty good set of problems to review here. Okay, let's look at 18. And that's what you do when you come to a problem you're kind of stuck at. You keep going and you come back to it, okay? You make a mark and you come back to that one. On number 18, we are subtracting, okay? We're subtracting fractions. Now, to subtract or add fractions, you must have common denominator. Notice this and this, they're common, they're the same, so we can simply write the whole fraction as 4x minus 5, right? And then just subtract on top. So what I'm going to do is distribute this to both terms. So I'm going to get rid of it here and make it a minus positive. So 3x minus 1x is a 2x. 2 plus 1 is a 3. Okay? All right, let's move on to number 19. Subtracting fractions. Must have common denominator. When you have rational expressions, you must factor. Okay? So x, the factors of 2 that get 3 when added, 1 and 2. Both positives because they're both positives. Now, ask yourself, what's missing in the first one is an x plus 2. All right, so I'm going to go ahead and put x plus 2 on the top and bottom. All right. Now, I'm going to go ahead and write one large fraction with the, notice your answer choices went right back to this one. So I'm going to go ahead and write down x squared plus 3x plus 2. And I'm going to go ahead and distribute the 2x here to both terms as I go. Okay, don't forget that's a minus sign, so just go ahead and distribute the minus sign to whatever's up there and be done with it here. So I'm going to have 2x squared after multiplying 2x times x, 2x times 2 plus 4x minus 1. Okay, so now I have a trinomial that we see in written normally in descending order, where you've got your largest term, x squared, x constant. So we want to continue factoring here. Okay, so now that I see, so let's see what happens after I factor here. I might need to put this back into, the x plus 1, x plus 2. So let me see what happens here. We know that the factors of 1 are 1 and 1. That's easy. The factors of 2, when added to the factors of the 1, must get us a 4. So if I did, let's see, if I do 1 and 2, so that's going to be 1 and 2, that's only a 3. Okay, so notice that I can't factor this trinomial. It's non-factorial. We can't factor like we've been factoring, because the factors of the first and last term, when added, cannot get that, or subtracted, cannot get the middle, right? You take the last, the outer, and the inner, and you add, right? And if you try to reposition your factors, and say, instead of putting the 1 and 2 here, you put the 2 and the 1 here, and you try it that way, right? It's still going to get 2 and a 1. That's a 3. So we can't factor this way. So it stays like this. Okay? All right. Moving to 20. All right. Moving to 20. And then we are done. Okay? Number 20, we're subtracting fractions. In order to subtract, you must have common denominator, and we do. So we're going to go ahead and go to one fraction, writing x minus 4. We minus, so distribute this to all your terms up there, and we get x squared minus 2 minus 5, right? Combining like terms, we get x squared minus 7 over x minus 4. This is not a difference of squares because the 7 is not perfect, meaning you can't take the square root of 7 and get a whole number, so it stays like that. Okay? That's it.